is from Charishma C, is the first time speaker at Software Architects Meetup. So give a warm welcome to this session. Much encouragement. Alright, so over to you.
Thank you. Hello. So I'll just get into it. Before we try to understand product, platform, where both of them stand and what do we do today in today's technology, let's try to understand how software architecture itself has evolved over the years. It's seen significant evolution over the years, where way back in the 1960s, we had these things called mainframes, and we had these huge batch processing systems that were running on these mainframes, and they were mostly used for transactional data. From there, we moved into a slightly better client-server architecture, where we saw the application layer broken down into two parts. Basically, you can see here the database or the back-end part and the front-end part. That meant once you move into the client server structure, you now have a UI and the application logic, the database sits somewhere else on an on-premise server, for example, and you get to access the application sitting at home. From your monolithic or mainframe architecture, you move to client server, but still you are sitting on a monolithic architecture for your application. That means your entire code base is one single package. If developers wanted to push changes to production, they had to access the entire code base, they had to make their changes and then redeploy the whole package itself. So updates would take weeks, sometimes even months. But one small advantage that came with client-server architecture is now you could sit at home with a desktop and send and receive data using a CLI tool or just a basic CLI from your desktop. From there, the big bang happened, www. So you started to see these websites and web pages come up. The world's first bulletin boards, web forms were uploaded online, and you started to see these desktop coupled, tightly coupled applications transition from a desktop client to a web page. From there on, companies started to look at breaking down the product architecture into further more modularity. That meant instead of tightly coupling your database and your application logic, you now look at separating the database out of the application and furthermore divide your application logic into multiple services. At the end of the day, these services still access the same database. The database is not broken down, but your application logic is. And this is nothing but your typical Windows-based applications with hosted services. From there on, you started to see virtual machines come to play. That meant you could easily create and destroy your applications running on some other OS, and you could do it in minutes. And that meant you could test your application more quickly, and you did not need a lot of hardware to get started. From VMs, companies like Amazon saw a business opportunity there, and they set up what we know today as AWS. So companies started to realize that instead of investing in hard bare metal servers, they could onboard their application into something like AWS and let go of their infrastructure efforts and just concentrate purely on their business logic. That's when companies like Facebook, Netflix started to really pick up because they could put the time and energy into their business logic. With that, you started to see some companies come up opening APIs from their website to third-party services. The very first companies were Salesforce and eBay, who made it possible for their website to be accessed from some other website or some other system where data could be sent and received. And you also see Netflix realizing that coming from an SOS or services architecture, moving to microservices architecture made more sense given the technology improvements that came with it. Why microservices? We start to see later in the slides that microservices can help you build applications in a more modular or smaller detail. That means you can treat each microservice as an application itself. And because of the technologies that were available in the coming years, one being containerization, companies felt it to be very easy for them to switch to a microservices architecture, use containerization and deploy, test, break microservices and build better ones. You can definitely compare containers or containerization to virtual machines. What's the difference? Virtual machines you can think as a bigger version of the same concept or a very similar concept. Container gives you the option to go down to the microservice level and I'll tie that microservice logic or code to every other dependency that the microservice needs to run. For example, your runtime tools, your libraries, dependencies, anything, and you could package into one portable file. And if I'm working on that microservice, tomorrow someone else, my team member, could pick up where I left off without having to go through the entire process of setting up their laptop, mimicking their dev environment, etc. So we saw that from monolithic to microservices, that's what has been a huge change. Where do we go from there? Before we deep dive into how to proceed from microservices, let's try to understand what a platform actually is and the misconceptions around platform engineering in the marketplace today. What is a typical example of a platform and more? So first of all, why do you need to look at platform and product separately? Because as you can see, the way you architect products has changed so much over the years. It has become a huge thing to just deploy and manage your product. Not just think about your functionality, business functionality and coding of your product. How would you actually make sure that product successfully reaches production and users are able to access your product, millions of users that too, and also make sure that you're making money out of it. So that means you cannot invest in the business logic also and the hosting and the infrastructure also in most cases. Huge companies, yes they can, but most of the companies today what they think of doing is only concentrating on their business logic and going to something like AWS, GCP or Azure for their hosting. They start with hosting and then they slowly move towards what else can AWS do for them. For example, go for their cloud native services and instead of developing something in-house, they onboard services like AWS. That's how companies like AWS make money. So coming back. Before this platform product, everything came up, there were traditional teams. There were development teams and there were IT or ops teams. So development, you all know this, development teams would finish their coding end of sprint, they would just push their code over to ops and ops would have to figure out how to run this in production, how did it work in dev but not working in production, etc. Slowly companies started to realize that big wall between development and ops need to go. It's no longer the case where you can work in silos where everything is the same today and tomorrow. So DevOps came into picture where developers stepped out of their coding hat and came into the world of DevOps where they had to also learn how to push code, how is this code being used in a microservice, how is my microservice being orchestrated, how do I deploy this code in production, make sure that there are no breakages in the deployment process, etc. That meant a single person is now expected to do the development work also and also make sure that the code that they develop reaches production safely, which again is impossible. That's where the concept of DevOps came, where essentially dev and ops work together in the best way possible, and that means every organization can see it differently. DevOps in every organization means something for that organization. You cannot define or restrict how you use it compared to Agile or Sprint. But still the concept of breaking that wall between development and ops came into play with DevOps. Now yes, okay, all is fine, DevOps came and now all your code is deployed in production very well and happy. No, that's not the case. Now companies started to grow and they started to observe that they want to build more products. They have different application teams doing different things. And that means each application team likes to code in a different technology. Each application team is pushing code in a different way, and that means the whole process of deployment, maintenance, and observing your product differs at each application level. So one step ahead of DevOps you have to think, because when you end up with multiple application teams working together, you have n number of tools that are being used. Today you will feel like one tool works well, but tomorrow there's another one that's released. Or the tool that you onboarded yesterday have changed their financial charges to you, or they're introducing more cloud native services and you have to now onboard that or leave the tool. Or they're sunsetting the tools that you picked 2 years ago. There are tools that will keep changing. But the point is, if you future-proof your architecture in a way where even if the tool is updated in the future, or if something breaks in your current code, you're able to handle it going forward in a more standard and consistent way. That means you have to start off in a good note before you push production code or before you even build application. That means what I'm trying to say is, if you standardize the way you use tools and if you standardize the way you check for tools for security vulnerabilities and make sure that you pick the tool based on organization decisions and not just the team level, it'll be better for you. So with that, you can now see that yes, DevOps is better than traditional development and ops, but it still means that the DevOps team is looking at a lot of tools and the DevOps team is trying to implement multiple tools if there are multiple application teams working in the organization. So you start to think in larger organizations where there are multiple product teams working together, a single DevOps team cannot handle all your application teams. So what do? Do you have a dedicated DevOps team for each application development team? Do you say that 5 members of DevOps go for one team and 5 to the other? No. That's where we are trying to say that if you standardize the use of tools, at least you get 50 to 60% of your work done, and the rest of the delta can be handled at the team level.
Yeah, when you say app team A, app team B, okay, so it's one product.
It's multiple products.
But each product has their own DevOps team, so they will have the standard practices and tools over there. So if, I don't know, I mean, let's say Devon, this company, I mean, it has product A, let's say, okay. I mean, that product A will have its multiple developer teams. It happens, okay, they have a charge of individual modules or microservices or whatever.
Yes.
And there is usually one DevOps team who does that. And all these, and it's only a fixed set of tools which is used for that product. I mean, you will not use Jenkins along with another orchestration tool.
Yes, fair point. So in companies like Devon, you don't need multiple DevOps teams to support your application development work. Yeah. But in companies, for example, the company I work with, we have a list of products. We have product suite. Each product is different. Some products are Windows based, and they're all SaaS products, but some products are Windows based, they're not cloud native. Some are cloud native. And within cloud native, because some products were conceived a few years ago, the architectural decisions around that product matter then. And now when you're trying to build a brand new product under the same foundation, we're seeing that we have the opportunity to build with better tools. And architected better. A simple example is we did not, let's say, have central observability. Initially, we had logging at each level, but now we have the option to go to something like Prometheus and make sure that the whole logging process is better for this product. So we are caught in this buffer state where we have to revamp our previously conceived architecture, but at the same time we have to build better products today. Where do you go if your company is in a situation where each team is looking at a different product altogether? They have their own apps, they have their own technology, but the process of pushing the code to production, monitoring the production performance, making sure there is, you handle your errors, there is support to production is the same. The ops part of it is the same. Maybe the pipelines will differ based on the tools you use, but still you're looking at each product in a different way. That's when you will start to think, okay, let's have DevOps do this for this particular team, but then the same DevOps team can do this for this team. Does that make sense?
So in your company, it's like a single DevOps team looks after multiple products. Is it something like that?
At this point, yes, but we're trying to do better. we're trying to go towards platform, and that's why I'm trying
That
to.
doesn't usually happen. But anyway,
So it is very possible because if it is an organization which has acquired several brands and hence acquired several products as well, it depends on what you've inherited. So you might have product specific teams who are developing the product or maintaining those products, but the DevOps team is part of the parent organization. All such is nice. Possible.
Yeah.
I can say as living proof, it's happening because I'm seeing it in my company, and this time still trying to figure out what is CloudOps, what is DevOps, what is platform. Do we even need a platform, etc. Maybe we could talk about it offline. Okay. So I was trying to tell you that DevOps doesn't solve all your problems, especially when there are multiple product teams. Your single DevOps team cannot handle. There's a lot of cognitive load on the DevOps team because there are so many tools that they have to expertise in, and they have to actually set it up and build pipelines, for example. So that's when you start to look at, can we at least pick out the common things out of all your product development processes and pushing to production, and the rest we'll take a look later. So that common thing is your non-functional requirements. Like I said, the whole process of after your end of sprint, how do you make sure your code reaches production without breaking? That's the whole, in simple words. So what is your non-functional requirements? Your pipelines, the way you run your product, the way you observe your product, security, etc. And maybe even provision based on the apps that you're building. So that's when this term started to come up in the market, internal developer platform, or you can call it as it's an internal product for your app, for your company that is solely dedicated for your developers, where it is a PaaS product that is platform as a service, but just for your developers. What you're doing is you are essentially building a platform team that does the heavy duty work in the background, acquires tools, sets up these tools, configures them, make sure they are following your security principles, etc., and creates an abstraction layer on top so that the developers don't have to worry about the access, the configuration, etc. They can just come, pick the tool that they want, and maybe go ahead and build a pipeline for themselves. This is one example of how you can use your internal developer platform. But there are multiple ways you can do it, and I'm sure right now you're thinking that it's not going to work for your company or it might work for your company. As you'll see ahead, it's different for every organization, but this is one way to do it. The point is, it's simple. If you have multiple people trying to do the same thing, you try to find the common areas of that and try to at least get how much of a percentage of the work done in a standard way, and then let your individual product teams take it from there. That point where you let your individual product teams take it could vary across companies. And in some companies, like this example, you may not even need this platform. A single DevOps team will do. They will build your pipelines. You are happy building your code and pushing it to production. And that DevOps team is worrying about making sure that the deployment is okay and your releases are okay, production is okay, etc. So as you can see, multiple application teams looking at multiple tools, and when you try to introduce a platform for them, you handpick some of the tools that are most needed, you build a platform on top of it, you create the abstraction layer, and you make sure your application development teams get access to that platform. Now, you may think that, okay, my tool is not in this platform. What do I do? The platform team is not setting restrictions for you, saying that no, from today you have to use this tool or that tool. If a team is insisting on something that is away from the typical tools pick, the development team can definitely add on top of, reach out to the platform team, and that tool can be added on top of the existing tools. It is fairly easy and possible. But you are not having multiple development teams, especially across geolocations, trying to do the same thing. That's the problem you're solving. You're not putting more restrictions to the product team, you're actually trying to help them. That's the whole point. But if you come in and say, no, from today you have to use only this tool, or you have to let go of that again creates a weird dynamic between your ops and development, and that's where we started initially, and that's not what we want. So what a platform is just trying to do, it's trying to just standardize whatever is possible. That's it. guys here, if you are, I'm sure you're still thinking this is just DevOps. This is still DevOps. It's a fancy word, platform engineering. But in the end, they're just doing what I do. They build pipelines, they build top tools. Yes, in a way you're right. Again, every organization is different. But if you are working in an organization where this actually makes sense to you, where you start, you don't have a platform today, you have haphazard development work happening, multiple DevOps teams doing different things, and your let's say your release cycles are crazy. You push code today and then you don't upgrade on a Friday, or you're super nervous in production even though everything works in lower environments. A platform may actually help your organization. So how do you start? As I said, a platform is still a product. You treat it as a product. You develop it in an agile methodology, and you develop it as you would develop any product. You start small. You identify pain points for development team today. What are the challenges that developers are facing? For example, they are done with code, but they are not able to push to production. Why? Is it time consuming for them to set up their laptop in lower environments, or something that worked in their lower environment is not working in production? Identify those pain points and try to standardize it. It's that simple. So you treat it as a product, and definitely a product means it will need improvements, it will need iterations. Tomorrow there will be better tools that are released and you will onboard those tools to your platform. That's definitely possible. So you have to keep in mind that this is ever changing, and you have to design it in a way where you can also change. As I said, every organization is different. You can call it a platform team, you can call it a DevOps team, DevSecOps, doesn't matter. As long as you're making it easy for your production. Yeah, I keep repeating that. Okay, so you're now at least able to see the advantages of having a platform. It makes sure that there are no duplication in the way you use components. So reusable components have a common infrastructure. There's faster development, and you support different product offerings. Yes. And then it fosters collaboration. Why? Because now you're forcing your developers and your ops team to come together and even establish a brand new team called platform team. So now that you have a fair idea of why you may need a platform, let's look at what is it in today's product architecture that is making our product architects think about what they should do differently as opposed to what they've been doing so far. So in today's world, you have to think about cloud. You have to make sure you're building your products in a way where it is future-proof. That means there are some basic concepts that you have to think of. Is your product scalable or elastic or resilient? That means, is your product able to handle high demand on a consistent basis? And is your product able to withstand sudden changes of demand, that is being elastic? How well are you able to make sure that your product recovers from faults? Or how is your product easily customizable or even able to extend to multiple other third-party solutions? So yes, you have to think about scalability. You have to think about how well you can scale your product with certain demand. You have to make sure that your product recovers failures quickly, and there is fault tolerance. And how flexible is your product? That means, will you be able to onboard new technologies in the future, or will you have to let go of existing features just to do that? Customization and accessibility. Is your product still able to cater to super specific client needs where you're able to customize the product without coding? So no code customizations. At the same time, how extensible is your product? For example, if you're building an e-commerce platform or if you're building a point of sale product, how easily can your product extend and integrate with different payment solutions as opposed to what you're doing today? With that, companies started to look at architecture with a more modularity in sense. That means you are trying to break down your architecture into smaller components as much as you can, so that you can achieve independent releases or deployment at the component level. And one good example of modularity is microservices. That means what is microservices? You guys already are pretty aware of the basic explanation. What you're trying to do, you're trying to break down your application logic into a bunch of smaller application logics. And you're trying to handle each logic separately, deploy each logic separately, upgrade them separately, maintain them separately, log on them separately. So a single team can concentrate on a bunch of services and not worry about the whole product. That's what you're trying to do. In the end, what you're doing is you're taking a big picture thing and then you're breaking down into smaller modules. That happens at the code level, at the product level. So as you can see here, for example, if you have a mobile app or a web app, there are multiple services responsible for each app, and then those services talk to other services for whatever their specific use cases. And the difference here is they are talking to their dedicated database. You saw in your service-oriented architecture that even though the application was broken down into multiple services, they were still talking to a common database. That means there was probably a database server dedicated for the entire application. But with microservices, what you're doing is you are breaking down the database also in sense. You are having your microservices deal with data on its own. There is an individual dedicated data source at the microservice level. So it's able to hold data, pass data, save data. And of course that will help you in your overall product going forward, and you can deal with individual services independently without affecting the other services. Again, you can maintain service versions differently. If you want to upgrade your product just on the payment part, you target a payment service and not have to worry about the other services responsible for your product. With that, a new problem came to mind for architects. Okay, we have microservices. We have hundreds of microservices. How do we make sure they peacefully talk to each other or communicate without breaking? And that means if I have 100 users today and 1000 users tomorrow, still these microservices are able to handle this load and not break. So there's really basically two ways of making sure there's communication between microservices: synchronous and asynchronous. Synchronous means without a response, I will not go forward. So I'm asking for something, give me, only then I will go forward. So such communication may be a good example for it is a payment transaction, or a user interface where you click something and you expect something to happen. So the services there are following your synchronous communication. Asynchronous, on the other hand, what you do in simple words is between the sending service and the receiving service, you fix a broker. This you can call it as a message broker, event broker, or even you can call it as an orchestrator. This particular tool that you fix follows a certain list of instructions to gather your message or event and pass it on to the receiving party without the sending service being blocked. So the sending service just comes in, says I want this, and goes back and continues with the other load that it has to take care. This little guy event is what the service is trying to pass on using this orchestrator. So that means you are not delaying your application performance just because of the use cases where your services have to come back with certain data. This will not work if these are mission critical transactions. Obviously in a payment interface or a user UI interface, such communication will not work. But for example, if you're placing an order, you don't expect immediately the order being delivered to you. So once you place the order service maybe will pick up the order information, your information, create an event, let go, and then go and handle a separate person who is trying to create a new order. That's a simple example of how asynchronous communication can work. Now, we are at the stage where you now know what is microservices, you now know what is a platform, and you are trying to figure out, okay, I know microservices is the way to go forward. I know that this is something that will help my product perform better in the current technology. Now, how do you go about making decisions to your product given that this is available to you today? You would obviously pick up on having your organization follow the DevOps culture. Again, that depends on how your organization views it. but in the end, you are making sure the coding happens easily and the deployment and release happens separately and easily. Both teams to a level are autonomous, but they are working together to make sure pipelines are created for this to happen. Now, this is not something new, right? We have companies who have already picked up on this culture. We started off with Agile, which was more of a process-oriented setup. Next, we had DevOps, which is more of a culture where there are goals for each person what to do. Then comes the CI/CD part of DevOps, which is again tightly coupled with your platform. Now that you're following the DevOps culture, you have identified that the more I automate, the more I create pipelines, it is easy for my development team to make sure that the code reaches production, it doesn't break. Now, the aim for you is not making sure today the release happens. The aim for you is hundreds of releases happen without breaking. That could be your aim. So there are companies who actually do it today. You already might know Amazon, Netflix, they make thousands of releases per hour per day, where in certain companies, one of which I am working on, we do annual releases or biannual releases at the max, right? How do we move from that to at least to a level where minimum feature flag based releases happen hourly, daily, weekly? Maybe in your domain it's not needed, maybe the domain you're working on may not need that many changes, but the idea is always to look at how much more you can do going forward. So there was one company, DocuSign, which adopted this DevOps concept and they achieved faster deployment, and they initially found it difficult for the culture to actually adopt in their organization, but once they looked at how CI/CD pipelines actually help for their production deployments, they were able to achieve better release cycles. The next thing you can do is automate everything. Yes, it's easier said than done, right? It's easy to say why have a manual person do something versus have the machine do it. Definitely automation is the way forward, whether it is testing, whether it is deployment, whether it is monitoring, fault, failure recovery, etc. So you have to start looking at opportunities where you can automate for your organization. One good example within the CI/CD pipeline is your developers are coding every day, right? But some developers have the habit of finishing the entire feature locally, testing it locally, and then committing after the whole feature is developed. Then see that at the merge level something failed, right? And they run to the DevOps team or whichever team is responsible to figure out the error, and then your release cycles are running and you're not able to meet your sprint timelines. So instead of that, if you have a culture in your organization where you commit at you commit at every stage that you're able to. You encourage your developers to push to main branch or the feature branch, however your repository is set up, more frequently, more often. At the same time, make sure there's automation tests done or tools in place that check for code at the branch level, at the commit level. You can go as deep as possible. In the first figure, you see that the tests happen at the branch level. In the second, you can see that the tests can happen at the commit level. So it all depends on how your organization is structured, but there are multiple tools available online, in the market, which help your developers essentially make sure that they are not introducing bugs in the main branch. So CI essentially is just this: how well are you continuously able to integrate your code into the pipeline without faults, without errors? That means the more you test, the better, obviously. So if you test at the commit level, at the branch level, at the main, after merge level, that's left to you. The more you automate, the more you test, the better. Next comes the CD part, the continuous delivery. Now, how automatically are you able to deliver the code that was pushed after testing into production? That is your continuous delivery part. And here you again pick up tools that help you along your pipeline. I would say that more than CD, CI is an opportunity where your product and platform can come together and make sure that less bugs are introduced into the main branch and you are not delaying on your release cycles. Next, end-to-end test. So before this, what did you do? You tested your code at the branch level. You didn't do a test where is the code working or not, breaking other features at the application level. So that is what you're trying to do with the end-to-end test automation. That means after your entire release is ready, is it working as an app or a website or whatever your product is it working? Now here you have the opportunity to automate your testing versus have a bunch of team members test your app or website. I personally have seen this in our organization where every release we would wait for the release, let's say 2025.1, and we would have a bunch of testers gather after the release is done, manual test everything, say go or no go, and then push to production. Still something will fail in production. So definitely manual testing is beneficial, but at the end of the day, automating helps you set up a systematic process which is not team dependent or human dependent. How could you do that? You first identify your test coverage. What are the things that are critical for your code to reach production? Can I automate the basic stuff? And that's where you start. And the automation testing scripts have to better pick up as soon as the pipeline pushes the code. That means as soon as the code is pushed to the lower environments, you have your test scripts picking up your application and testing it. Now, you may ask, okay, but I still have automation testing in my organization. Still I see production failing, but your lower environments passing. It is also important for making sure your lower environments mimic production as much as possible. That means configurations, environment setup, environment variables, test data, load of the production. You may work with 10,000 records in your lower environment, but your production will have millions. So that is also a key feature in making sure your automation picks up. Another example is while testing you may use an iPad, but in your Android app something fails. So definitely there is automation scripts that have to cover both your iOS or Android if that's the case for you. If multiple devices are involved, you have to make sure automation scripts to whatever extent can test at the device level. And that means after you make sure all your automation testing is done and your code is passed, you get this golden image that is a popular term in the market, which means it is error-free, it is perfect for production. It is production ready, basically. Now, how often do you think companies actually reach this golden image stage? It is the top companies. We saw that in a book that was released in 2014. There was quotations about top companies and how often they release. Some of you might have seen this picture, but here it is. In 2014, Amazon was able to do 23,000 releases a day, Google 5,000, and so on. And this was possible due to heavy automation, heavy CI/CD pipeline work, and efficient autonomous teams working from the DevOps side or platform side, development side, however you call it today. The point is, if you reach something like that, you are confident and you don't have to worry about scheduling your upgrades on a Friday, for example. Now, you may also try to research how is it possible? How is Amazon? It sounds insane, right? 23,000 releases a day. It could also be that some are very basic ones. They're not they're not breaking changes to the code, but still, this is something that is highly efficient. I just found a Reddit comment that tries to explain how this was possible. So someone was very interested to know, and the person, he or she says they're an SD in Amazon. They say something similar. They actually call it a two-pizza team. They try to structure their teams in a way where they can feed the team with 2 pizzas, not more than that. So your teams are small, and they're responsible for only a bunch of handful of services, and they're doing their goals specifically, and there is rigorous automation testing and deployment pipelines are used. This is an indication of you can understand how far your automation, test automation or CI/CD pipeline can take you. So from there, we start to see what else can you do as architects in today's cloud-native, cloud product world. You can also containerize microservices. Yes, something that you may already know, but if you try to understand why you have to containerize microservices. You can use microservices without containerization. You can orchestrate them without. You can do that, but by containerizing microservices, again you're doing the same thing. You're isolating your microservice independently, you're able to deploy and assess and log on that microservice. Your team that is specifically working on developing that microservice is not worrying about other errors. If there is a fault in their code or in their development work, they know that it is specific for that microservice. And at the end of the day, containerization helps you in a lot of ways. It's easy to manage, it's resource efficient, and it's easily portable and scalable. That means I can easily pass around the work that I've been doing at the container level for my microservices. Now you may ask, has this actually been done? We don't containerize microservices today, but why should we do it? Can we have any examples? There's a good example of Spotify. This is published in Kubernetes website itself. They chose to onboard Kubernetes as opposed to in-house orchestration of their microservices, and that took them a long way. This is at a time when Spotify saw a spike in their users and they quickly understood that current production infrastructure cannot handle this. They have to move from in-house to Kubernetes. These are really common transitions that you see today where in-house things are going outside. That means you're subscribing to something, you're purchasing a license, or even you're going to an open source tool. Every tool may have its own pros and cons, we'll see that later. But the idea is, again, future-proofing your architecture. As technology improves, as internet grows, there are more users using your app, obviously you'll have to handle that traffic, and this made sense for Spotify. Okay, you containerize your microservices. What else can you do? You can have a version control system established for your microservice itself. And these three things go hand in hand in fact. Once you establish a version control for your microservices, you can make sure that your code in fact is backward compatible. Why? Because you don't break in production. You can easily roll back and you can make these releases invisible for your front-end user, essentially. And you would reduce microservices risk. That means it's a basic concept where microservices start to drift away from their original functionality over the years because of a lot of things, changes in technology, code changes, manual changes, etc. But making sure there's a version in place for your microservice, you're trying to control your upgrades, at the same time control your development cycles. So why do you need to do backward compatibility? Okay, you do your version control for microservices, why do you need backward compatibility? Like I said, if you are introducing a major release, let's say 2025.4 is a huge upgrade, you have just moved from, let's say, an in-house logging observability to something like Prometheus, or you have onboarded Couchbase instead of a different database, and you're trying to push that change to this new release. All eyes are on this release. A good way to release such critical releases to production is canary deployment. This is a way where you control your deployment in production and make sure that the release doesn't hit all your users at once. This is similar to MDM systems. If you are aware, a few years ago it came up in the market where you're releasing your app at the user level. It's very similar to that. You're not upgrading your application immediately. You're control testing your upgrade, for example. You're identifying a bunch of users and you're releasing your new code or new application to a particular list of users. You're making sure it doesn't break, then you go to the next. So this was actually something quite common before also in desktop applications, where you would schedule your upgrades in a rollout. Rollout was what they would call it, where the upgrades would go on for weeks and you would identify group of users and you would actually push the package, or you make sure that desktop at those user levels are receiving that package in a controlled manner. The same way, in this case, it's not a package, it is your release. Your actual code is reaching the users at a controlled fashion, making sure that if at some point something breaks, you can quickly roll back, and because of backward compatibility, the user may not know what service is being used, which version of the service is used. If 10 services are being upgraded, you can roll back 5 services because of the issue you saw, and the other 5 services obviously can be upgraded. So at the back end, each app is using different versions, but at the front end, the user is not realizing that change. And the next thing you can do is set up a central logging system, or observability is the common word world in cloud today. So you are trying to make sure at every touch point there's logging, and the logging is so efficient and so legible that once an error happens, your developers don't have to break their head to find out what went wrong to understand the log. As already mentioned, Prometheus is a good example for central observability. Here you are able to get information on your errors in real time. You're able to monitor your applications well, and you are also able to troubleshoot your applications in a more easier fashion. The next thing you can do after making sure your backend is microservices ready is go to your front end. So this is something quite common in product companies which are UI heavy, where there are a lot of users coming into their website or the traffic is heavy, and they want to be able to change a particular part of the UI without having to touch the rest of it. What do? Again, modularity, break down a big thing into smaller things, deal with them individually. So following the microservices architecture, you break down your UI components individually, and you are now trying to make changes, deploy and monitor at that component level. Facebook in fact was one of the first companies which used this method, and they were able to handle the spike in traffic. So the next discussion for your product and platform and how to go ahead as a software architect is, what tools do I select? So some of you might have visited this site. There are thousands of tools available today across different domains, each attractive than the other. So you as an architect maybe have to, you're responsible to pick the tool that is supposed to be used, or you're at least trying to assess what works best. In most cases, you're not starting from scratch. You're working in a company where something is already being used and you're trying to transition to something better. In most cases, yes. In very rare cases where you're building something from scratch and you have the freedom to pick tools, go crazy. But in the first example where you're trying to onboard, there are many things to consider. The last two definitely. Is the new tool that you're trying to pick following your security best principles? Is your security team approving of this tool? All these discussions will happen when there's a platform in place, because you have to now introduce this tool not just for your team locally, but for the platform. So there are other teams trying to approve the tool that you're trying to say you want. The other example is financial implications. Yes, there could be situations where it's better for you to go outsource your features instead of building it in-house. A good example is on top. Going to AWS, for example, for their cloud native services versus doing something in-house may be beneficial for you. A good example is going for EventBridge or SQS instead of in-house developing an event-based architecture where it's handling events with in-house development work. Another good example is Snowflake, the tool that is quite popular these days. It is a very popular data warehousing tool, you can say, and you can now decide if your applications are sitting on SQL, which was open source back then, and everyone liked it, and you had a database server, so you set up your SQL. Now you want something better, so you can, for example, an example that is valid for my company. There are multiple products individually having their own database servers. Everything is on SQL. Now, if I want to go to a cloud native technology compared to where I am today, Snowflake is a very good example. In fact, we did onboard Snowflake for that very reason, where we are trying to transition from individual application level databases into something where there's a common data warehouse pulling in data from different applications, so a different new product can come up called analytics, and it can access all your different product level application data in one place instead of building multiple scripts on the SQL level. Another good example is again something that we did in our company is onboard Couchbase Kapala instead of having in-house data syncing. For those who are interested, you can research online. Couchbase Couchbase in itself gives database services, and recently they came up with something called Couchbase Kapala, where they have data sync features made available at a very efficient level and it's cost effective for someone who's already subscribed for Couchbase versus us who are trying to work on data sync services in-house and observing, let's say, replication working or not, data being sent offline and online. Such use cases are actually better handled when you go for something like Couchbase. So again, your work for your in-house development teams reduce, but at the same time you're making sure that it's someone else's problem. This is not your problem, it's someone else's problem. And that is how it starts, right? You, with AWS, GCP or Azure, you let go of your bare metal servers and then you went to AWS and you said, it's not my problem, it's AWS's problem now. I'm only concentrating on functional logic. And now you are at a level where even at a microservices level, it's not my problem. I go to cloud native services. I onboard AWS Event Bridge. I don't want an eventing microservice on my own. You handle it. So that's where it's easier for companies to come up today and it's easier for you to get started in a way. Another factor in deciding what tools to pick up is the domain. Another good example is I work in the retail domain. And in the past, where AWS was still coming up, there was a reservation in retailers that AWS will steal my data. Because AWS is also Amazon, and Amazon is an e-commerce website, and I'm a retailer. So there was a lot of reservations around that, and we ended up going for Google Cloud, especially for the retailers who are more fast-moving goods, as opposed to luxury goods. So they are more concerned about AWS or Amazon being a competitor. These days, no one is thinking about that. They know AWS is different, Amazon is different. It's quite, well concept. But back in the day, that was actually a deciding factor for architects to say, no, I'm a retail person. I'm in the retail domain. I cannot go for AWS. I have to go for GCP. But still, there could be other concepts that are applicable. Maybe I'm not aware in the domain that you are in, where there is an overall preference on which cloud provider to go to. And that again becomes a factor for architects to select. So with that, you are now probably aware, okay, there's product, there is platform, and now what do? Do I do DevOps, DevSecOps, or platform engineering, and how do I go about it? So that was what I was trying to say. And in closing, as you saw, product and platform need to work together, and that's the future. You can't sit and say, I'm a developer, you are ops, I'm not talking to you. So, and you as a developer may have to learn new skills, and you as an ops person may have to be more familiar with development practices. And as a person who is seeing this happen today, this is the go forward. So for your product and platform architectures to be smart and efficient, you have to have a collaborative approach. So make sure in the end, your development costs are reduced, your go-to-market is faster, and you have better efficiency overall as an organization. A few references for my presentation. Thank you. Any questions?
So we have various solutions, right? So these have numerous limitations. These are some limitations. So why we are talking about a data warehouse solution? Because we have a data fabric, data mesh concepts, which is gaining traction.
Yes. See, again, the answer you already know. It's based on your organization. This example worked for our organization because we had at least 6-7 products sitting on Microsoft SQL, each with its own database server, and each with its own configuration, each with its own table schema. And now, if I want to introduce analytics into the mix, I want to be able to know what is the data coming in from product A and also product B. Right? So that's where, and also the kind of data that you will, because we are in a retail space, a transaction data, customer data, basically. And the records are in millions. And the way the pricing structure happened with Snowflake they, if I'm not wrong, they, yeah.
Snowflake setup is really okay. It was right because it has so many limitations. We moved from Snowflake to Delta Lake, from Delta Lake to Instead architecture, database we are trying to develop Instead architecture. So Snowflake or Databricks, Data Lake, you know, has so many limitations in terms of cost, in terms of latency, in terms of compute, consistent. So now every company or every organization is custom basing services.
Okay.
It's not about dumping the data in the lake house, data lake. On top of that, we are creating models. On top of that, we are creating data domains and products. This is not the case.
Yes.
Those days are gone. So we are giving to the data fabric, data mesh concepts, so that we can build the products quickly.
Okay. To answer your question, I'm coming back to the same concept. I am a product company building products to retailers. So the more products I have under my bucket, the more money I make. The more updated my products are, retailers are interested. Another concept is, if I make it too high-fi, retailers are not interested. These guys are interested in selling their products. They are not interested in technology, right? Retailers are more concentrating on how well the product is for them. If it's a bag, it's a luxury goods like Tory Burch, they are concentrating on making better bags. They're not concentrating on whether I use Snowflake or something better. Is the job done? That's the mindset retailers have. So it's a very domain-driven decision. Another thing, the advantage that Snowflake brought for us is the move from individual data servers to a common channel where each application, even though Windows-based, without cloud native, could create their own channel into Snowflake, handle the data individually. At the same time, another brand new product called analytics, which we want to sell to our retailers, also can look at Snowflake. That's all we wanted, right? We are not going for, let's go for the best in the market. We are going for get the job done, cost me less, make money. That was the decision around Snowflake for our company. The pricing structure is what, if I'm not wrong, attracted us towards Snowflake. I'm sure the product business analysis team looked at a bunch of tools before.
Last question, so when you talk about this platform and product, so are we building reusable APIs and logic across products?
Across?
Products.
Yes.
So are we building reusable components, reusable services, or reusable API across products? We have so we talk about some products, right? So is the same as we are applying across the products?
No, again it will vary based on your product, right? I have out of the 10 products, maybe 2 are only cloud native. So the others are desktop based, which did the rollout on weeks together, right? What reusable component you put in there? Wherever you are able to, you will. And when I say reusable components, I am trying to say, okay, I have analytics as one product. I have one more brand new point of sale solution that in fact is true for our company. We are building a cloud native point of sale solution. So both use observability, right? Both are cloud native. Prometheus can be used for both. That's what I'm trying to say. But we have the older point of sale system, which is not cloud native, which is Windows based. The logging happens how in Windows based? Each service level, there is a folder where the text file sits, and then it logs everything. You have to go and see where. Some other service breaks, you have to go somewhere else and see. But Prometheus gives a common place for all logging. You just have to pick the product you are interested in, the service you are interested in, what broke, pick up the logs, and done. Whether you are a consultant for your analytics product or point of sale product, one place to go. That's what I meant by reusable. And another example for reusable is, now my analytics product team, application development team is separate. Maybe they are in Mexico and my point of sale development team is in India. Right? Now, so you have a DevOps team in Mexico, talk to the development team there and the DevOps team here, or you will keep the DevOps team in one place and then you will make them work 24/7, set up pipelines for this person also, that person also, own their production, everything. So when it comes to platform, ops, DevOps, DevSecOps, everything, they own production, that's their responsibility, right? Application development team are owning the development part. Ops team are owning production. If something breaks in production, they have to jump in. And for that to happen, their main concern is, how do I make sure nothing breaks in production? So I make a pipeline. I make CI, continuous integration, where I check the code at the individual level. So my ops guys are not struggling day and night to analyze something in production because it is already caught in lower environment. So that was the idea. I'm not sure if I answered the question.
I'll have to stop here. We'll take it off.
Yeah.
Right, so thank you, Charishma, for doing this for us.
I was super confident overall.
Now, we hope you come back and update us how your product is going. We are curious to see what part you take. So, thank you so much. Small gift from us. And also a t-shirt for you. Thank you. Alright guys, let's do a lucky draw. So for you to participate in the lucky draw, you have to give us feedback. So everyone who gives us feedback here will be part of the lucky draw. I will show you, we'll do it live. So meetupblog.com, you can use your Google Docs, sign in with the pin, then you'll see a big button called as feedback form on the top. So I'll give you all maybe 2 minutes to give us feedback and then we'll do the lucky draw. And what are you guys getting? Plants, of course. So I have lots of plants and we'll give this to you guys, okay?
It's out of